going to start that now. We are now recording. You may want to pin my screen because I'm going to do this. And let's see, I might move this up over here a little bit. So can everyone see that okay?
Yeah.
Great.
Yep.
Cool. So I snuck this in the front of the dev lunch line because I feel like we have all heard about Docker, talked about Docker, and from time to time, everybody or many people have said to me, you know, should we be using Docker? And I had no idea. And I'm still not sure that I'm convinced one way or the other that we should use Docker. So what I wanted to present today, I've been playing around with it sort of in personal projects and stuff like that, and I feel like I have a pretty decent understanding of how it works and how we might use it for our projects. And so I just wanted to present what I have found so far. This will be kind of like a crash course in Docker. At the end, I will give a demo of using Docker for a development environment. And I would also like to present sort of the pros and cons as I see it, and also as you see me using it. I'm sure you'll draw your own conclusions. And then hopefully, time allowing, we'll have the opportunity to discuss whether this is something we seriously want to consider as part of our workflow at ThinkNimble, and making this a part of all of the projects that we do. So given all the hype and such, you're probably wondering, what is the deal with Docker, like Jerry Seinfeld? So what we'll look at today is what the deal is. We'll talk about Docker in brief. We'll talk about the history of Docker. It's been around probably longer than anyone here has realized. And actually, just as a brief survey, who has not heard of Docker? So I take that to mean everyone's heard of it. Who feels like... Wait, Victor, are you going to say something?
I was just going to say that I think I've heard of it because, and I'm seeing like containers. I think I, read something about, containers, but I don't really know a ton about it. So I was kind of just waiting to, hear more about it to see if it sparked any recognition.
Gotcha. Cool. And who feels like they have a vague understanding of what Docker might be used for? Corey raised his hand. Nate. Okay. Who has actually used Docker and feels like they have a strong understanding of it? Okay, cool. All right, that's helpful because that'll help me kind of decide what to say going forward here. So yeah, so we'll talk about briefly what is Docker, what is it used for, its history, where it came from. Then we'll talk about deployment versus development use cases. Docker is overwhelmingly, I would say, it's a deployment tool more than anything else, but we can use it in development. Although at times, in my opinion, it kind of feels like you are trying to fit a square peg in a round hole, as they say. We'll talk about containers versus virtual machines. I think that it's helpful to define containerization and Docker in terms of what it's not, and in terms of what came before it, which are virtual machines. And I'll explain what both of those are as we get to that. And then I want to talk generally about what our options are for dev environments. We all know how we do dev today. I want to zoom out a little bit and look at all the different ways we could possibly do dev that I could think of. There are at least 4. There might be more that we come up with as we talk about this. So I want to look at all of those, and then I want to look specifically at how Docker compares to those other options for a dev environment. And then finally, overall pros and cons, and hopefully a small discussion, if we have the time, about whether this is something we want to do. So briefly, Docker is free and open source software, and comes with all of the pros and cons of free and open source software. It is backed by a company called Docker Inc., which is a commercial company, so they have an enterprise offering, what you might call bullet number 4 here, a platform as a service, or PaaS, and we'll talk about that in a second. But by and large, the Docker has been built by the community and then curated by that sort of core group of Docker supporters, which is really interesting. And one of the biggest benefits, I think, in open source software, most of our company is built on open source software, is the strength of the community and ecosystem around that software. So that's one of the bullets on here. It is, at this point, mature, stable, and widely used in production. It's used by many of the big players, including Google, Amazon, IBM, and there's also a lot of commercial ecosystem support. You can deploy Docker Swarm to AWS, which is containerized versions of web apps. You can deploy it to the Google Cloud platform, and support is growing every single day. Docker can power a platform as a service. So Docker itself is a platform, but a platform as a service, I just wanted to throw this jargon out there because you probably will hear it if you haven't heard it before. Platform as a service is a play on software as a service, SaaS, and you'll probably also hear infrastructure as a service. It just means basically AWS is a platform as a service. They sell access to the ability to create containers, create virtual machines, create the infrastructure that you need. It's all virtual, but you can create the infrastructure that you need to host your services. So that's a platform as a service, and Docker has probably seen a lot of adoption precisely because it can be used to power those platforms in a straightforward and easy way, and I'll talk about that again in a second here. It's highly cross-platform. In the demo, I'm going to show running Docker on Windows, Linux, and Mac OS, and with some very edge casey kind of situations, it is pretty much the same workflow on each one of them. I had the hardest time setting it up on Windows, which kind of came as no surprise. Mac was actually the easiest, which was a bit surprising, and then Linux was somewhere in the middle, but more towards the easy side, and we'll look at that. And finally, and I think this is a really important point about containers in terms of just the buzz and adoption around it, is that containers encourage, and I'll define containers soon, containers encourage sharing and reuse. So one of the cool things about Docker is that you can go to Docker Hub and you can find a container for just about anything that you need. So for example, I needed a container that had Python 3.8 that also for Festi supported, one of our clients supported location services, PostGIS and Postgres. So it had Python libraries that were enabled to interact with PostGIS, and I found a container that was all set up for that. So I didn't have to do, all I had to do was name that container and spin it up, and then I had an environment wherein I could run Python code that could talk to that library in PostGIS, and somebody else had already built that for me. And Docker Hub is a great resource for all kinds of stuff. Now, of course, it's all open source, so you kind of, the warranty is sort of as is, but there are a few officially supported packages out there, like the Node package is officially supported, the Python package is officially supported, where you can pretty reliably get exactly what you're looking for and have it be of high quality, and have it been vetted by the community at large, and bugs fixed and security updates enabled and so on. Docker is trendy, and I apologize for how noisy this is, but what I did is I took Docker, Heroku, AWS, React, and the phrase virtual machine, just search topics, and I plugged them into Google Trends. These are all what I would describe as trendy technologies over the past 10 years. So you can see this starts in January of 2010 and takes us all the way through the present day, just to see, just for fun, to see how Docker, this is not at all scientific, but just to see how Docker has trended over time. So Docker is this blue line here that has slowly climbed since 2013. Yeah, a few interesting trends there. Whoops, that was the mouse wheel. Virtual machines started pretty popular, almost as popular as AWS is today, and have gradually declined in popularity over the past 10 years, while Docker has risen in popularity. AWS and React, of course, have just kind of skyrocketed. They're super popular in terms of Google searches, and Heroku has just hung out down here. And actually, I was kind of surprised by Heroku. I would expect to see Heroku to have tracked similarly to Docker, and I guess the only explanation that I have for that is that people are probably searching Docker to how do I use this thing, because it's not straightforward, whereas Heroku pretty much is a plug and play sort of thing, so they're not searching Google so much for that. They're probably going straight to Heroku.com. Pure speculation, but that was an interesting a trend to me. So you can see Docker has been growing in popularity for the past 10 years, and really started to take off somewhere between 2013 and 2015, which is about the time that I heard of it. But if you look at Docker's history, it was actually founded in 2010 which was actually surprising to me. I didn't realize it went back that far. And just a couple of years before that, containerization technology became a thing. Linux containers and C groups and such were introduced to native Linux, and that was the technology that Docker was sort of built around in the beginning. The first versions of Docker were written at Y Combinator or coming out at Y Combinator in 2010, 2011. And does everyone know what Y Combinator is? It's a venture accelerator based on the West Coast. It's very well known. It was founded by a guy named Paul Graham, who in 1995 built a website called ViaWeb. He wrote it in Lisp, and he has plenty of blog posts about the experience of writing web software in Lisp. The short story is he loves it, and they're very interesting to read. But he sold that to Yahoo in 1997, 98, made bank, and then a couple of years later started Y Combinator to raise up the next generation of web entrepreneurs. And I believe Airbnb came out of Y Combinator. A lot of big names. I would just Google it. Hacker News is a Y Combinator production, and so if you've ever stumbled on Hacker News, or if you read it regularly like I do, you probably think about Y Combinator pretty frequently. 2013, Docker Engine was first released. So Docker Engine, when we refer to Docker, we're really referring to the Docker Engine, which is the thing that powers it, and we'll see where that sits in the architectural diagram of Docker in a minute. 2014, Docker was integrated into Windows Server. IBM pledges support. I really wanted to just show this history to kind of give you an idea, first of all, how long Docker has been around, to kind of support that idea that it's pretty mature technology at this point. And then also to point out that its history is basically just, the theme of its history is the big players in tech throwing support behind it. And again, this is kind of speculation, but I think if you follow the money, the reason is containerization gives you all of these companies, Google, Windows, IBM, Cisco, Red Hat, they have tons of big beefy servers, and containerization versus the previous technology of virtual machines allows you to subdivide those servers more efficiently, and so you can sell those bits of server at a higher margin. And so I think that's the number one reason why Docker gets so much buzz and has garnered the support of such high profile organizations. And so I think that's essentially why Docker is such a big thing. And there are pros and cons to that. I would think if you go out there and look at the blog posts that are published about Docker and stuff, always keep in the back of your mind who's funding that. The more adoption that Docker gets, the more these big companies benefit, because the more they can divide up their considerable infrastructure into smaller chunks and sell those at a higher margin, which I think is interesting. In 2019, Microsoft announced full Docker support in Windows Subsystem for Linux, and I played around with Windows Subsystem for Linux, or WSL for short, and it's actually a pretty cool thing. As somebody who's a big fan of Ubuntu, this is Ubuntu essentially running natively on Windows with direct access to the hardware and a thin layer of adapters between Linux and Windows, and it's pretty cool. You have a native Ubuntu environment on top of your Windows computer, and it's, for me, that's a very productive environment to work in, especially if I have to switch back and forth between Windows only things like Photoshop and After Effects. And so over the past couple of years, Microsoft has embraced technologies like this, specifically Linux, I think to compete with Apple, which did a very good job over the past 10 years capturing a lot of developers into its ecosystem. So Microsoft is sort of fighting back against that now, and doing a pretty good job with it. Many of us use VS Code now, and the integration between WSL and VS Code is pretty cool, and so on. So I'm gonna have to move quickly through these slides because I do want to make sure we have time for the demo, and that's and potentially time for a discussion at the end. But do sort of raise your hand or stop me if you have any questions as I go through this, because I am going to try to go quickly. Docker deployment.
I have a quick question.
Sure.
Quick question. Sorry, I joined late. Did you send this out beforehand, or
I did not, but I will share it afterwards.
Okay, cool.
Yep. So Docker deployment versus development. I think Docker was built firstly with deployment in mind, and when you look at the interface, the command line interface to Docker, you'll feel that. And then just like a lot of the ways that Docker works is very reminiscent to configuration management tools like Puppet or Ansible or Chef, and I'm just going to throw those out there. You can Google those on your own. But essentially, the idea is that you probably heard of development operations. That's a jargony term, DevOps. There has been a movement over the past 15 years to stop manually configuring your servers and instead write code that automatically configures your servers for you. And Docker incorporates a lot of ideas from those other tools and a lot of the patterns that you see in those other tools, where you have configuration files that are declarative specifications of what the resulting environment should look like. Then Docker can read those configuration files and produce an environment that looks exactly as specified, which is a very powerful tool and allows for massive scaling of these systems. Docker's not necessarily intended to be used for development environments, but it can be, and we'll look at how I've set that up. But I do feel like as you're setting this up if you're setting this up from scratch for a development environment, you're fighting against Docker's sort of natural inclinations towards deployment, and you're doing some steps that I think, when you're just trying to get a prototype up, are going to feel really unnecessary. But once you get it up, it's a beautiful thing because it promises to unify your deployment environment with your development environment. When you produce something that you can use in development, it is, in theory, something you could use for production, although probably not with the security considerations and stuff that you would need in a production environment. But you could take your development environment and scale it out 1,000,000 times over. Once you've written your configuration in Docker, there are tools that would allow you to do that in Google Cloud and AWS. And I think that's what really gets devs excited about it. Declarative configuration means that your deployments are immutable. So once you have something working, and it does take some finagling to get it to work, to be honest, but once you do have something working, you can be pretty guaranteed that every single time you run that configuration, you're going to get exactly the same thing, because the configuration is you just declare, like, this file gets copied over here, this image gets installed. What you say you want is exactly what you get, and you get it every single time. There are no side effects to that, and I think that'll become clearer as we dive into it. So just briefly, your deployment options. I just wanted to put this jargon out there so you guys can make a note of this and maybe dive deeper into it. I'm not going to dig deep into this right now or about deployment in general, but deployment largely falls into two concerns conceptually. One is configuration management, which is the configuring of a single server or a single environment. Let's not even talk about servers. So that's the idea that I need Python, I need Node, I need these things in my runtime environment. I need environment variables and things like that. So when you have a configuration management system, you're specifying the things you need in your environment, and then those things are being automatically placed there by whatever tool you're using for configuration management. Then orchestration is sort of a higher level concept. Once you have your configuration done on an individual environment level, then you get an orchestration management tool that can take those multiple different environments. So say I have a web server that I have a configuration for, I have a worker server that I have a configuration for, maybe I have a database that I have a separate configuration for. I need to orchestrate these three different players in my orchestra so that they can talk to each other, they're networked together, and things like that. So in the Docker world, Docker is used for configuration management, and then Docker-Compose is a separate tool that interacts with Docker, which is used to compose multiple configurations, multiple Docker configurations into sort of a constellation of cloud infrastructure. So if I say I want my web app to be able to access my database on port 5432, Docker-Compose is what makes that connection happen. But Docker by itself just says I have a database that exposes port 5432, and then I have a web server and it exposes its own ports or whatever. Docker-Compose spins both of those up and then connects them after the fact. So just some other tools to throw out there that are, I think, a bit older than Docker, and they operate mostly on virtual machines or in cloud infrastructure like they would operate on EC2 instances in AWS. Are Ansible, Chef, Puppet, SaltStack. There's a long list, but these are the ones that just kind of came to mind. All of these do configuration management for sure, and then some of them also have either built in or they have an additional tool, like SaltStack has Salt Cloud, which does orchestration management as well on top of the configuration management provided by the core tool. So Docker is just another in this lineage of development operations tools, and I just want to kind of point that out.
I have a question really quick.
Yep.
Are you going to be talking about Kubernetes and how that relates to this? Because it always seems like Docker and Kubernetes go hand in hand, particularly like Docker-compose. So I don't know.
Yeah, I'm not because I wanted to focus. Kubernetes is 100% a deployment tool, and maybe you could run it locally and make a dev environment out of it, but I wanted to keep this focused on development environments, and so I didn't dig into Kubernetes, and I don't plan to for this. But yeah, that is a good question. Kubernetes clusters are closely integrated with Docker, and I guess that's the closest, or that's the most that I'll say about that right now. And there's a lot of cloud support for Kubernetes.
Cool. Yeah, I just wasn't sure. Appreciate it.
Yep, no problem. Okay, development options. So now I want to transition just to talking about development environments. I think this diagram probably sums it up better than the previous bullet points. So on the left, you have like the least isolated version of how you could set up a development environment. On the right, you have the most isolated version. We probably could come up with other options, but these are the ones that are top of mind for me. So on the far left, we have just install everything directly on the system. Just install Python, use your system Python. If you need a new version of Python, also install that version of Python, and then figure out a way to point to it when you need to run your software. Go ahead and install Node on the system, Postgres, Redis, whatever other services you depend on and need. I think intuitively we all know that ends up being just a mess, right? Like you have pieces of your system, of your application dependencies scattered all over your computer. Now, if you're only working on one project, that's probably good enough, right? Like if you only need your system Python or your system Node version, stuff like that, then by all means do that to create your prototype. But once you introduce a second project that may have a different set of dependencies, then you're running into conflicts between what you already have on your system and what the new app may need that is different from that, or you need to change both of your apps so that they have the same dependencies. Either way, you have a conflict, and it's overhead that you don't need because you just want to write code to make your software work. So there's the next step up, which is pretty close to what we currently do in our development workflow, which is to establish virtual environments. So here we've taken things that are particularly difficult to manage across projects, namely Python and Node, and we put those in virtual environments so that when we install a different project, it doesn't interfere with the project that we already have installed, and vice versa. This is not 100% segregated though, like Postgres and Redis in my example here are still living on the system. And so in a sense, those have virtual environments sort of built in, because when you, or at least Postgres does, because when you create a new project, you just create a new database, and that new database is separate and apart from any pre-existing databases and stuff. But I'm sure some of you guys who have worked on the back end have run into issues where Postgres 11 did not play nice with Postgres 12 or 10, and you had different projects where you were downloading data from staging or production, and your local Postgres version didn't match, and it's not ideal, and it's not fun to handle those situations. So that's not a fully isolated environment. The next step up, this is where I put containers, somewhere between our current virtual environment workflow and virtual machines. And to make this make sense, I think I need to just move ahead into sort of an explanation. I'm going to skip over. I think we all kind of generally understand why isolation is good. You can repeat your configuration exactly. There's no conflicts between environments. When you build something up, if it's fully isolated, you build it up, it doesn't interfere with things that are already there. When you tear it down, it doesn't leave pollution behind in your environment that could potentially conflict with something in the future. And it also emulates a remote cloud environment where you'd be where you'd have very similar concerns, where you'd be like spinning things up and down. But I'm going to skip past this and just talk about virtual machines versus containers. So I think the best way to explain this is to like go back to the beginning of computing, where you had hardware and you had punch cards, or you had some way of feeding in code to that hardware, and it could pretty much just run one, what they called at the time, routine, one function. So you plug that in, it's processed, and then it spits out a result. And that was fine while hardware was not very powerful. But it was always everybody's dream of like, well, what if I could get multiple of these functions running at once, or even like group these functions together into applications and have multiple applications running at once. And so over time, operating systems developed as hardware became more powerful. So by the mid 80s, operating systems were pretty much a fixture. And then at that point, we also had graphical interfaces for those operating systems, and you could run multiple apps at a time. You could summon them up, you could dismiss them when you wanted to, and you could manage multiple applications. Over time, over the next decade, hardware became so powerful that then you had these massive servers that people were starting to build as the internet came about in the mid to late 90s, that people started thinking, well, like, one operating system is too little for all of this computing power that I have. I have this big data center, and all these people are coming to me, and they want a server. They want a piece of my server space, and I can only sell them one server at a time, right? And they can't afford that because the rent on that single server would be too high for this little guy who just wants to host a little website. So the solution there was they said, okay, well, what if we can create like a layer between the base operating system and deploy multiple virtual operating systems on top of that. And that is sort of the concept of the virtual machine. It's very similar to the evolution that happened from the very beginning of computing to get us to operating systems where you could run multiple apps. Now we have operating systems that can run multiple operating systems that can then run multiple apps and stuff. And so we were able to take large chunks of hardware and subdivide them almost like apartment buildings and sell them piecemeal, and also scale them up or down more fluidly than you could physical hardware. So like you could give somebody a big virtual machine and charge them more for that with more CPU cores or memory or whatever, and you give someone else a smaller virtual machine with less access to that stuff. And so it made economic sense to do this. Containerization, I would just say the simplest explanation of what containerization is, it's the next evolutionary step in that same concept. And I think the best way to, and it's an optimization. The best way to explain that is to look at a diagram like this. So I was previously talking about the different layers of the architecture. So at the very bottom layer, you have your hardware, and this might be a big, beefy server or something like that, or even like a gaming desktop that you have at home, something that is more than capable, memory-wise, computing-wise, to handle multiple operating systems. But by default, you only have one operating system installed on it. So most operating systems then have a virtualization interface called a hypervisor, which can manage multiple virtual machines. And we'll look at this in a moment. And then on top of that, we have multiple virtual machines that have their own operating system, their own libraries, and their own applications running inside of them. And so if I wanted to use a virtual machine, just as a point of comparison, as a development environment, I spin up a new virtual machine. I have a clean, brand new computer that's completely isolated from my host operating system and my host machine and whatever's installed on that. It's a blank slate. I can install whatever I want in there, and it's not going to interfere with anything else. And that's a good feeling as a developer, because then like there are not going to be any nasty surprises. You're just dealing with that. And if you get in a bad state, tear it down, build a new one, start over, and you're back to that blank slate again. You can run multiple of these side by side, and the hypervisor can allow you to network them together. So again, you're mimicking your cloud environment where you might spin up multiple servers that all can talk to each other. And this is a very valid way to do local development, and then also sort of mimic how you would later do deployment. So how are containers different? Well, they just take the operating system out of the virtual machines. And what they do is, in simple terms, they just share a kernel. And in some cases, if you're running on Linux, they share the kernel of your underlying machine, because all Linux machines are fundamentally based around the same kernel, and that's why they call it the kernel. It's at the very center of the operating system. Now, there are different distributions of Linux, like Red Hat, Debian, and they all maybe add or tack things onto the kernel, but the kernel doesn't differ between them. And so what this gives you is a few advantages. So first of all, you've cut out the overhead of this operating system. You don't have to allocate disk space to this operating system. You don't have to allocate memory to this operating system. And even in a VM environment, there is some resource sharing, but for the most part, virtual machines, if you allocate 2 gigabytes to it, it's going to hold on to that 2 gigabytes of memory or whatever. Whereas with a container, the sharing between containers is more flexible. The scheduling between operations within the containers and memory management or memory use of the containers is much more flexible. So these things dynamically scale. I guess the simplest way to put it, they dynamically scale significantly better than virtual machines do. With virtual machine, you've essentially installed a whole new computer on top of your computer, and with a little bit of flexibility, that's about it. With containers, you've added a new running process to your computer, and when that process is idling, it's not consuming resources. When that process is at full tilt, then it is consuming resources, but it's negotiating that with the other containers that are running on the machine. So again, containers are an optimization. They are a better use of the underlying hardware resources than virtual machines are. And this is, a big deal for cloud providers and people who have significant hardware assets and resources, because that means they can chop those up and sell them to more people, essentially. And that's a good thing for them. Go ahead, Nate.
Can you go back to the last slide? First of all, I think it's really cool, and I like how you visualize this. So just to understand, you're talking about the kernel. My understanding about the difference between a kernel and an operating system is sort of limited, but basically you were mentioning that different distributions of Linux share the same kernel. And so I guess my question here is, obviously it seems to make sense to me that you cannot have a container running Windows and a container running Linux and a container running OS X on the same server with Docker. But it sounds like you can have a container running Linux distribution number 1 and a different container running Linux distribution number 2 on the same server.
Yeah, and I should point out that containers are specifically a Linux technology. So whereas virtual machines, you could virtualize Windows and you could virtualize, because you have the entire operating system in there, you can virtualize Windows and you can virtualize OS X on top of any arbitrary operating system. But with containers, you're talking specifically about Linux in all cases. Yeah.
That base operating system can't be Windows right now. There's no software that.
Yeah, so it can be, and so again, because Microsoft, but I think there's a virtualization layer here. So for example, when I first installed, this is a great question because this is kind of nuanced. And I meant to explain some of these things. So when I first installed Docker on Windows, I got a Docker app that then created a virtual machine on top of Windows using Windows hypervisor, which is called Hyper-V. And so that Linux machine running in a virtual machine is what was running my containers on Windows. So it was one step removed. But then I upgraded my Windows computer to their fast track. They have like a Windows Insider program thing. And they are Microsoft is actively working on making it more native. And so in Windows Subsystem for Linux 2, it's no longer a virtual machine. It's still virtualized. It's still some sort of adapter interface between Windows and Linux. So it's not as efficient as Linux running on like bare metal or something like that. But it is more optimized than it was before to run on top of Windows. I think it's the same. It must be the same story on OS X. Although OS X is based on Unix, which is a similar kernel but still different. They must have a virtualization layer between the host operating system and the container manager and Docker. I didn't dig into the specifics of that too much, but there has to be something in there that's virtualizing it. But that's a great question because again, I'll underscore that like containers are specifically a Linux technology. I did run across a container that was running like Windows Dev Server or something, and I'm curious about what the story is there, if that has a Linux kernel or something, but they're calling it Windows for some reason. Maybe there's an adapter inside of that container. But with that exception, maybe a few exceptions like that, it's primarily a Linux technology.
Thank you.
Yeah, and I think that also goes to show like the greater trend of Linux is already the majority of servers on the internet, and it's clear that Microsoft, like if Microsoft is embracing that, that's a significant thing. They used to try to really push the Windows Server and stuff like that, and they still sell a lot of Windows Server based machines and stuff like that, but they are embracing Linux now in a way that I've never seen before. And so I think that's sort of telling of the overall trends. And then also just how efficient this technology must be for Microsoft to think that it makes economic sense to use it. So I want to give a brief example of dev on a virtual machine. There is a tool called Vagrant. Let me bring this up. And Neil probably remembers this. We used this at Aspire. I used this previously. My workflow for many years was to use Vagrant as a configuration management for a virtual machine, a configuration management tool for a virtual machine that I would then do my development in. So I think the best way to look at this is this next slide here. This is the Vagrant file for the Aspire app. And this is written in Ruby. And I'm not going to dig deep into the syntax here, but basically had some configuration at the top to name my virtual machine, to grab a specific image, which was hosted actually by HashiCorp. So similar to Docker Hub, HashiCorp, which are the makers of Vagrant, had a community. I don't know if I can jump to it real quick, where you could, yeah, I'm not going to spend time on that, but you could go and you could find existing virtual machine images. So they were trying to do what Docker has done very successfully, where you could say, well, I want an Ubuntu image that already has Postgres installed on it, or something like that, just to get me started. Here, I was just using a sort of naked Ubuntu installation and then doing the configuration from there myself. I gave it a static IP address so that I could do networking, and it exposed port 8000 so that while I was in development I could do manage.py run server, and then I could go to localhost 8000 on my Windows machine, the host operating system, and I could see Django from there, and I could do other development on Windows. And so I had this nice back and forth between Windows and Linux. I preferred to use Windows for pretty much all of the graphical programs like my text editor and stuff like that. But then I had this Ubuntu box that was running the back end, and the advantage of that for me was that when I deployed this, I was going to use Ubuntu. So every time I just had the ability to practice working with Django inside of an Ubuntu environment. So when there was a production issue and I went out to the remote Ubuntu instance to troubleshoot that and interact with Django there, it was extremely familiar, because it was exactly the same as what I was doing locally on my machine, because I was interacting with a remote Ubuntu server. So that was a big advantage of doing that. And I think that is a big advantage of using Docker. It's a very similar feeling where you remote into your Docker system and then you interact with it in the Linux environment. And then I'm just going to quickly scan through this so you can see the configuration that went behind this. I'm not going to highlight these too much, but like here we're allocating memory to the virtual machine, so I gave it 1 GB of RAM. And then at that time I also used Salt Stack to provision the virtual machines. This is the configuration. So Salt, we could look at those if we have time at the end, but Salt is a declarative syntax. It's a YAML file that says what the server is going to look like when it's done spinning up. And so basically by running Vagrant, I would run a command called Vagrant up. It would create a virtual machine, and then it would configure an entire development environment for me, and it was ready to go. And I didn't have to manually install any dependencies or things like that. Yeah, I think that's all I want to highlight here. And then finally, here I'm forwarding a port. I'm creating a private network so that I could create different VMs that could talk to each other. And then I'm creating a shared folder. This is important. If I have my text editor on Windows and I make changes, it's automatically synchronized with the Ubuntu thing. So I make a change to Django, and Django will auto reload, and then I can preview those changes in my browser. So that's what the synced folder is. And this concept, all of these concepts are shared with Docker. Docker is just running a container at the end of the day and not a virtual machine. And we will see that shortly. I wanted to run through some important things. Again, I'm going to go through these really quick because you'll see these in the demo as well. But these were things that confused me at first. And so it's like you could look at the documentation, but I'd rather just pull these out and put these up front. I would have loved to have seen these bullet points first, because I think it would have really gotten me oriented. So hopefully it helps you guys. Docker is used to create individual containers, like I said before, whereas Docker-compose, the third bullet point, is used to manage multiple containers. So that's an important distinction. A Docker file, like the Vagrant file we just looked at, is used to define first the parent image that you're going to depend on, and then all the steps to build a single container image. So you need a Docker file at the very least. Docker-compose.yml file, a YAML file, is used to coordinate multiple containers. So once you have definitions, Docker files defining multiple containers, you can point to those different Docker files or point to different images and have them coordinated by Docker-compose, and we'll look at that in a minute. A Docker ignore file is like a git ignore file. It uses the same syntax, and it can be used to exclude files that you don't want to be copied from your host system into the container. I think by default, what you do with Docker is you give it a context to run in. So usually you would say, in development, you'd say my local folder is your running context, find the Docker file in this folder, and then all of the commands use this folder as their root folder going forward. So if you don't want files copied over from that command context into the container, which generally you don't want all of them copied over, you only want a few copied over, the Docker ignore file is there to speed things up and prevent you from copying over hundreds of megabytes of data into your container. And we may look at that a little bit. That's not too important. Very important thing, the build step of Docker and Docker-compose is separate from the run step. And this, once I understood this, it all clicked for me. This was an important thing. So you have a Docker image, like what you might find on Docker Hub, or what you might specify with your Docker file. That image has to be built, and then once it's built, it's self-contained. Then separately, you choose to run that image, and then the image is running. I thought maybe this would just be one command, like Docker up or something, like it was with Vagrant, like Vagrant up, and then you'd get both the build and the run sort of back to back. But you have to be aware of these as two separate steps of the process. And again, we're going to look at a practical demo of this. You don't have to memorize all this, but I just want to throw these important concepts out there first. Build arguments, likewise, are separate from environment variables. So build arguments are used only for the build, and then environment variables are used in the way that you would traditionally expect them to be used. When your application is running, then it picks up the environment variables, and you put them in a .env file and point Docker to that, and they're used in the way that the backend devs are probably familiar with, even the front-end devs with the .env.local file in Vue.js and stuff like that. But again, build is separate from running, build arguments are separate from environment variables and need to be specified as such. And I have an example of that using the npm private token. Running containers are just like any other process. So again, the big difference between virtual machines and containers, or like the easiest way to describe the conceptual difference, is that containers are basically just processes running on your machine sharing the kernel, whereas virtual machines are literally a whole nother computer sitting on top of your host OS enabled by virtualization technology, the hypervisor. And then finally, containers are completely ephemeral. When you spin them up, they just live in memory. When you spin them down, they're gone. But you can use volumes, that's what Docker calls them, volumes, which are folders, directories, to persist data. And I did have to do that with our Postgres database in the example that I'll share in a minute. So that concept of volumes is important. So let's look at a Docker file. So this is the demo I'm going to run today. I need to switch over to my personal browser because this is in my personal repo. Any questions at this point while this is taking forever to load? Alrighty. So this is a Docker file this is the Docker file specifically for the backend. If you're not able to read it, I can zoom in. Is that better?
Yeah, that's better. Thank you.
Okay, great. This is the Docker file specifically to run Django. I built this Docker demo repo from the Bootstrapper, from the latest changes in the Bootstrapper. So this should be more or less up to date with the latest stuff in the Bootstrapper. And then all I did was Dockerize it. So I didn't change anything in the Bootstrapper. All I did was add Docker. So I added 2 Docker files, one for the front end, one for the back end, and a Docker-compose file to coordinate them. And then I don't even think I added a Docker ignore file. And I'll show you why in a second. So the first line here, I will go through this more line by line. The first line here grabs an image from that I found on Docker Hub. So what I did was I went to Docker Hub Python and click the first link here. And this is the Python Docker official images repo. I scrolled down a little bit and I looked at all of the different available Python images. And if you scroll to the very bottom, you see Python 2 is no longer supported, so they don't have any Python 2 images up here. But they have lots and lots of options, and I'll briefly kind of explain what's going on here. Anything that is Alpine runs Alpine Linux. And I would put this in maybe in the con category of Docker as a whole, that images you select, you have to be, when you select an image, you have to be aware of the version of the distribution of Linux that is running that container. And it's actually kind of annoying, to be honest. So for example, Alpine Linux has a different package manager than Buster, which is a version of Debian. And you just kind of have to know this if you're writing Docker configuration files. Stretch Linux, I don't even know what that is. And then they have Windows Server Core up here, which was the anomaly, and I was like, how are they running that? Because this is Linux, and so on. And then there's also just like a wealth of options, and it's kind of like, well, which of these do I choose? What I've found is, for example, if I choose 3.7 Buster, then I'm going to get Python 3.7, but it's going to auto increment any patch version. So if Python 3.7.8 is released or 3.7.9 is released, then it's going to automatically upgrade me to that version. And then you're like, well, wait a minute, I thought Docker containers were immutable, but they can actually change underneath you if you're not careful about the image that you select, because this image can change underneath you, which could change certain assumptions about your environment and stuff like that. And again, I probably put that in the con category, and we can talk about that more later. So what I've done here is I've chosen Python 3.8 Slim Buster. I chose a Debian distribution because I'm most comfortable with Ubuntu, which is also a Debian distribution, and so that's an environment that I feel good with. It's also what we deploy to typically is a Debian distribution. But again, you have to be attentive to that. Yeah, so that's sort of the first order thing when you're setting up Dockerfile and you're thinking about Docker. Then I just know these environment variables help with watching for file changes in Python, so we're configuring the environment just like we would any new Linux environment. We are enabling these environment variables, and this is taken from a different cookie cutter kind of Django repo that uses Docker and stuff like that. So this is sort of a best practice thing that you have to do, and you just kind of have to know that again. Then we're installing Python dependencies, system level dependencies that help us install Python packages and run Python packages. And so we have Build Essential, GCC. Some of you who have worked a lot with Python may recognize these and the significance of them, or you just install them because you have to and don't really know why. That's fair too. Then there's libpqdev, which lets Python interact with PostgreSQL or via scicop G2. So you need this library installed so that you can build scicop G2 so that you can interact with Postgres from Python. Then we have Pillow, which is in our Bootstrapper, and it requires, by default, it requires at least these two libraries to support JPEGs and PNG compression. And then finally, we install Python 3 pip just to make sure that is on the system. We set the working directory. So this is the name of the working directory that you'll find inside of the Docker container. This is similar to like when you go to a Heroku instance, you SSH into a Heroku instance, and you end up in the /app folder. When you access your Docker container instance, you actually have a full file system, but your app is going to be under /app. And you can specify that here. So we're saying we want to start in /app, and we want to copy over the pip file and the pipfile.lock file. And this is a quirky thing, is like, well, if I'm starting from scratch, with the Bootstrapper I have a pipfile.lock, but if I'm starting from scratch and I'm using Docker containers, how do I even generate, I need a pipfile.lock file to install Python, to install Python dependencies, but how do I even generate that in the first place if I can't get the container running? And that was sort of a catch-22 that I ran into there, and not specifically with pip the pip file because that already existed, but with Node I didn't have a package lock.json file, so I had to I had to run npm install outside of the container first to get my package.lock.json, and then I could run the container. It was kind of strange. And I want to highlight this because I don't want to, I think there's a lot of literature and there's a lot of videos and blog posts out there about how great Docker is, how easy and straightforward it is. And I just want to highlight some, and it's going to look easy when I do the demo, but I just want to highlight some of the struggles here. I think that once you get this configuration just the way you want it, it's beautiful. Getting there is a slog, to be honest. And if you need to make changes to Docker or your infrastructure for your app that necessitates changes to Docker in your development environment and stuff, then this is something you have to worry about, whereas maybe you didn't have to worry about it so much before. So I just want to be very even-handed with my assessment of what it's like to use Docker for development. Finally, we run pip3 install, and then this is interesting. We're using pipenv just because that's what we do in our current development environment. But we actually, inside the container, want to install all of the dependencies at the system level and ignore this pip file and just use pipfile.lock because essentially the container is a virtual environment. So there's no need to have another layer of virtual environment inside of your container. So we just install inside the container. We install everything at the container layer. And again, this is something that I just found in a cookie cutter Django project that was using Docker as a best practice that they recommended. And also, if you try to just run pipenv install, you will get an error. It doesn't work inside of Docker.
So basically, pipenv, we use it because it's a virtual environment, but inside Docker, you don't really need it.
That's right. That's right. Yeah. So we could just go back to requirements.txt if we picked up Docker, or we could do it this way. And then finally, this is kind of odd. But I have a start script, which is basically just a shell script that runs that runs manage.py run server. That's all it does. We need to copy that over to the container, and then the container will later run it as part of Docker Compose. We'll look at that. In fact, let me just go ahead and open up the Docker Compose file so we can look at that. Any questions at this point about this Docker file?
Yeah, I have a question. Couldn't you leave some of these files in a shared folders outside of your container, that since they all share the same underlying kernel?
You could, yeah. So when we look at, well, they share the kernel, but they don't share a file system. The file system is
the file system separate. Okay.
Separate, yeah. And so when you, if you want to have a shared file system, you have to explicitly say, you have to explicitly attach a directory as a volume to your container, and then it can be shared. And that's what I've done in the docker-compose.yml file here. So if we look at, I'm going to skip past this and just look at the server block. So this is the block. Everyone see that okay? Good. This is the block that specifies the Django container. So it says, go to this Docker file, which I put in the project root /compose/server/Dockerfile. I just saw someone organize it that way, and I liked that way of organizing it. The Dockerfile can live anywhere because you can point this line of code to anywhere you like. Restart always means that if it encounters an error, the container will attempt to restart, and we'll just keep doing that until it works. So you can kind of fiddle around with it until it works. Ideally, it should start up and be fine from the beginning, though. The command to run, so /start, this is from the perspective of the container. So when we copied over start, we put it in the root of the container, and so the container will run /start. I ran into an interesting problem here where, not with this one, but with the client, I was running node Alpine, so I was running Alpine Linux, and my start script started with #bang bin bash, like I start every shell script I've ever written, and it told me it couldn't find the start file. Well, the underlying error was that node Alpine doesn't have bash. It only has sh, which is a trimmed down version of bash. And so I had to change the header on my start file to #bang bin sh, and then it would run. But that was a 2-hour problem that I didn't need. That was really frustrating. And so again, Docker is sort of like what they call a leaky abstraction. It doesn't, it's really nice that you can specify a whole server, so to speak, at this level with this few lines of code, but there are a lot of little gotchas in there, and you kind of have to know what's going on under the hood in a way that Docker implies that you don't, but you do, if that makes sense. So just calling that out there. Here's where I attach the volume, though. So I'm saying take the current directory represented by the dot, map it represented by the colon to /app inside of the container. So this is what creates a shared directory between my host system and the container. And so on my host system, when I edit files, they will automatically be synced with the container here. And this is what this line, or these two lines, are essentially what enables you to use Docker for development. This is the key to being able to modify files that are then picked up by the container. Typically what you do in a deployment scenario is you copy things wholesale because you're not concerned with editing them after the fact. So you copy over your entire application directory, like your bundle of code, and then the container has that and just runs it verbatim. But in a development context, you want a mounted volume that you can then edit, and then the container picks up those changes. And then it depends on Postgres, and this is a pointer up here to the Postgres YAML. If any of you worked with the bitbucketpipelines.yml file, this should look very familiar. This is bitbucketpipelines.yml is essentially a Docker Compose file. I think with slightly different syntax, but that's essentially what it is. Here, we haven't specified a Dockerfile, we've just specified an image. And this is where what I was talking about, the build step being separate from the run step being different. This image is pre-built, so there's no additional build step. It's just an image that we can run, that's ready to go. And I'll show an example of how I've done that with these files as well later. We define some environment variables, so the name of the Postgres database, the user, the password, and then the volumes that we want to mount here. Now here, the volumes we're mounting are for a different purpose than they were down here. Here we're mounting volumes so that we get data persistence, so that when we tear down this Docker container, the data that was in our Postgres database will live on our computer in var lib PostgreSQL data. That way, when we tear down the environment, rebuild the environment, any development stuff that we put in the database is still there. We don't have to add our test users back or anything like that. We can always delete volumes whenever we want, but for development purposes, it's probably better to persist that data. We're more used to that than not, I think.
And is this something that we would do on the server that we're on production server if we wanted to tear down an instance?
Well, I think I've read that using Docker to manage databases is not good practice. So what we probably do in production is only use Docker for our backend and any worker servers. Oh, that's a weird glitch. Mainly for our web server and worker servers and any other services that we sort of have in the cloud. But the database should probably be like RDS or something on AWS. It should be a separate service. That's a good question. That is that seems to be the consensus, is that you don't put databases in Docker unless you intend for them to be experimental and ephemeral. Any questions before I move on to this? The client is specified very similarly to the server. The difference is that the Dockerfile is based on a different, see if I can just jump over it to it here. It's based on a different image. In this case, it's based on node Alpine, node 12 Alpine. Here's where we pass in a build argument. So it picks up the build argument that we pass in. I'll demo that in a second. It copies over npm rc. In this case, we actually don't have to copy over package-lock.json. I thought I would have to, but that was optional. We changed the working directory to /app/client. So here we've again mounted the root project directory into the container, but we want to specifically go into the client directory so that we can run npm install there. This sequence of events here is very similar to what Heroku does in its post-build step for us right now. It CDs into /app/client and runs npm install. And then finally, instead of having a start script here, I just am running a command. And this is an interesting syntax where each word in the command is an element of a list. Don't know why, but that's the way they do it.
So right now, with our virtual machines, we like you on AWS on Heroku, both the Python app and the Node app exist on the same machine. You can access them both in the same virtual environment. Whereas here, they exist on two different containers. And the reason for that is because if we wanted to combine them, we would just have to find an existing image that combines Node 12 with Python 3.8, and that would just be like a pain to.
Right. Yeah. So I think actually that's a really good point. And this goes back to like talking about containers as an optimization. One of the issues with running virtual machines, or even just like doing development directly on your system, is that there's so much overhead to a virtual machine that it doesn't make sense to add another virtual machine just to add a small running service in it. Your incentive is to just add that service into your existing virtual machine and layer those together. With containers, because there's no overhead, your incentive is to create many small containers that are separate. And what that gives you is the ability to create highly composable containers. So I can easily swap out one container for another. Does that make sense? Like that concept of highly composable? It's kind of like, sorry, go ahead.
Would you also say that if you wanted to say scale just the back end, you could just spin up more Docker containers for the back end without having to worry about also doing it for the front end?
Exactly. Yeah, exactly. So you also don't get the baggage of having multiple services mixed together that then have to be scaled together. You can scale things more independently. Again, it's going back to that idea, isolation is good, and then the sort of meta benefit of that to the community at large is that if you build a really good, actually let me jump over to to this diagram. So Docker images are sort of built up in layers. So the base layer is the Alpine image. And then someone came along and said, well, I want to build Node on Alpine. So they built the Node Alpine image. I guess I should rename this Node Alpine. And then someone else came along and said, well, I want Vue CLI on Node 12, right? So they came along, they built Vue CLI on Node 12 on Alpine, right? And all of these are shareable via Docker Hub, and they also do one thing really well. So this reminds me sort of like functional programming concepts, where the whole idea is like you create a few small, focused, highly generic functions, and then you're able to compose those functions together to create more specific, to realize specific use cases. That's sort of the same idea that's being applied here with containers. With VMs, because there was so much overhead, it was certainly not as easy to do, and it was certainly not as efficient to do that. It didn't make sense economically to compose VMs in that way. Because there's so much overhead to them. And then finally, you can create a custom image on top of the work that other people have done for you. And that's essentially what we've done here with our Dockerfile.
So the Dockerfile is also an image. That's like what an image is a Dockerfile. The
Dockerfile produces an image when it's built.
I see.
So it specifies, it specifies the build steps for an image. Yeah, that's great. That's a great question. That concept of building versus running really confused me. So I think that's one of the key things to kind of wrap your head around with Docker. So with Dockerfile, I say, for example, this is the image I want to start with, Node, and I want to put my custom app directly on top of the Node image. So my Dockerfile specifies the steps that get me from the base Node image to my custom image. Then I can do Docker build, and I end up with my custom image as an image on my computer. And then I can actually share that image back to Docker Hub.
So like every...
Go ahead.
Sorry, Nate. I was just going to ask, so really it looks like the process for like a developer on the team would not really need to know the underlying mechanism of how you build an image for one of our apps. Somebody would just need to build the image and distribute it to everybody, and they would just need to know how to run that image.
That's right.
Is my impression.
That's right.
Yeah. Okay.
Yeah, and that's what I want to discuss. We may not have time today, but that's what I want to discuss. It's like I think the way that this would work on our team is you'd have to have some like Docker experts who build the images for everybody else and troubleshoot problems with the images for everybody else. I don't think it's reasonable to expect everybody on the team to learn Docker deeply enough to write their own configs. Certainly it'd be welcomed, and we provide people with resources to do that. But I think there's so much going on here, and again, there's so much implicit knowledge that you need to have. Like that shell script problem that I ran across, it finally clicked for me just because I have a lot of experience with Linux, that I was like, oh, Alpine Linux probably doesn't have Bash. I don't know if you guys would have had the same realization. You probably would have spent days and days on it. And that's not a knock on you. It's just like that's just the way it is. There's so much you have to know in there. So sorry, Perry, you wanted to say something? I'm gonna do a demo.
Are we gonna move on to like an area of implementation, like where we could see this fitting into our what we do right now, or is that later down the line?
That's the next step. Yeah, because we only got 20 minutes left, so I got to do that now. So what I've done is created this Docker demo, and I'll give you guys access to this repo at some point. I'll probably just push it to the ThinkNimble libraries. Let's look at the top level source here. So this should look exactly like our bootstrapper, except it has a compose directory in it, and then it has docker-compose.yml up here. The compose directory is broken down into client and server. Client just has a Dockerfile in it. Server has a Dockerfile, and then that start script that I mentioned before. The start script is simple. It runs migrations, and then it runs the server. You can ignore this stuff. Again, that was just best practices stuff that I read online. And that's it. That's all I added to the bootstrapper to get this working. So let's take a look. Is this text super tiny? I can't figure out a way to zoom this in, unfortunately.
It's pretty tiny.
Let me try this. We'll do this.
That's better.
Okay, cool. All right, so this is Windows subsystem for Linux. So this is essentially Ubuntu. So this is sort of proof of concept that this will work on Linux, on Windows. Let me open the. I just accidentally restarted Docker. I'll open the Docker interface for Windows here, if it wants to come up. So this is the Docker interface for Windows. It's nice. Linux doesn't really have an interface except for the command line interface, but this will show you containers that you have running. I don't have any containers running at the moment, but we'll spin some up. Oh, I guess I do have Docker demo running already on here. So what we'll do first then is tear that down. So if I go into the Docker demo directory, this is what we were just looking at on Bitbucket. To tear down my environment, I run docker-compose down, RMI, which just removes all of the images, and get rid of everything. And that we should see it spinning down the client, the server, and Postgres. And then this will get us back to a clean state, and I'll show you how a new developer would build this up. I'm also going to do a demo on Mac, where I've started with a clean box over there. So here it's removing all the images.
And you would do this like every day, or
you don't necessarily have to. You can leave the images running if you like.
Right.
This is like if you get in a bad state or something and you just want to nuke your environment. That's what you do. Okay, so suppose I'm a new developer, right? I'm coming in. There are a few things that I would need to get set up before I could get to this stage, right? I need my SSH key, and I need that hooked up to Bitbucket. So I need my Bitbucket account and all of that good stuff. I also need my npm private token. And I need that to be placed in my bash RC file. So if we look at my bash RC, I have a few nice scripts in there, but there's npm private token is in my bash RC file, and it's being exported. So that needs to be there. And then I also, in my SSH directory, I need my, I got a lot of keys in here, but I need my ID RSA, my private key, in order to be able to interact with Bitbucket. If I have all of those things, then I can clone the repo that relies on Docker, and I'm in here. So once all of my credentials are set up, what I can do is docker compose build, and then I need to pass in my npm private token as a build argument. And this is where what Corey was saying was relevant. If we've pre-built an image, you don't even have to do this step. But this is, I wanted to show you the difference between building and running that I've been talking about. So we'll run the build. This will take a minute, probably too long for us to let this play out right now. But here it's running through, let's see if I can scroll up. It's not letting me scroll up. Okay, so it grabbed the image. Typically, it would have to download that from Docker Hub, but it's already been downloaded on this machine. It ran the steps in the Dockerfile, and now it's getting to the point where it's running the steps to install the pip dependencies and stuff like that. So you see it going through all of the stuff that the backend devs probably recognize of installing Python files here. So I think I'm going to let this run in the background and switch over to the Mac. Let me get it started up here.
So while this is also running, so somebody had made this recommendation to me actually, but I didn't know enough about Docker. I didn't know if anybody else knew enough about Docker. But when I was trying to rewrite the initializer script to the Bootstrapper to work for Mac, somebody suggested that we just do it on Docker, and that way you always have the same environment running the whole time. That you would just initialize on a Linux instance, on an Ubuntu instance, and then you would run your initializer script. Do you think that would be a better avenue for us?
I'd have to think about it. I don't see the immediate benefit of that. Like what exactly would that get you out versus running it on a normal machine?
Well, for example, if you updated your OS, you could have a new error that
to avoid. Okay, yeah, I see what you're saying. To avoid like Bash, like the Bash script problem that we had, like the incompatibility that we had for the longest time between Mac and Linux.
Yeah, or if you switched to ZSH and you didn't have Bash anymore.
Yeah, 100%. That would totally be. Yeah, that's a great use case for this. Yep. Yeah, I had forgotten about that, but that is great. So as this is spinning up, containers are starting to appear running in the Docker interface. And they give them random names like Pensive Perlman here. Okay, I'm going to switch over to the laptop because I think when I time this, it takes like 6 to 8 minutes. Everyone can see that, okay? Switch my view.
Yeah.
So this
Are you running OS X on a virtual environment on Windows?
No, this is one of the extra laptops that we have. It'll actually say Bruno's MacBook. So here, same thing, same setup. If you look at the bash profile, I've added the npm private token here, and I also have the IADRSA file in my SSH. Again, there's no additional setup than that, but you do have to have a Bitbucket account, you do have to have the SSH key, and you have to have the node, the npm account, and the node private token. I think I've already cloned. Sorry, say that again.
Mind zooming in a tiny bit?
Yeah, how do I do that on Mac in the terminal?
Plus.
Command plus, yeah.
Okay. I don't have a command key. Oh, it worked. Okay.
The
start key, the Windows key worked. Okay. Thanks. Okay, so if I go into my workspace, have I already cloned this? No. So we'll do git clone git at bitbucket.org, booster.j, docker demo.git. So we clone the repo. So I'm a new developer, so these are the steps that I take. Now, I created a separate branch here called images. So I'm going to check that out. And in this branch, what I've done is I pre-built the images as Docker Demo Server and Docker Demo Client. And I've uploaded them to Docker Hub. So once I've done that, as a new developer, I would have to log into Docker. And I think I may have done that. Oh yeah, I haven't installed Docker on this machine yet. I wanted to demo that. Okay, so I'm a new developer. How do I go about installing Docker? I just do Docker download. Select the version for Mac. We'll get the stable version. It's about 500 megabytes. I don't know if you can see that. Okay, open that up. Got about 10 minutes. Okay, I think we can do this in under 10 minutes. Okay, it opened up on my other screen, so we'll drag that in here. A window popped up on the other screen, but it was copying it over. Go into applications. We have to manually start Docker. It doesn't start it doesn't start automatically. There's probably a way to configure it to do that. Okay.
From the internet.
Close those things, and we see the Docker icon up here, and it starts up. So it's going to take a minute. When you install Docker on Windows, it doesn't come along with Docker Compose, and when you're using Windows Subsystem for Linux, I know very few of you care about this, but you install Docker on Windows, and then you also install Docker and Docker Compose on the Linux subsystem separately. When you install it on OS X, Docker and Docker Compose kind of all come along with it. I may need to restart my terminal here, though. Let's see. Nope, there's Docker, and there's Docker Compose. Great. So now we'll log in with Docker. Okay, so there I logged in with credentials that someone would have set up for me. And now I should be good to go. So I would run, again, I'm on the images branch, so this time I'm using images that have been uploaded to Docker Hub. So now all I should have to do is run Docker Compose up. Oh, sorry, it's a new directory, so I have to copy my environment files. And this could be automated, probably. So I need to copy the one in my client folder and the one in my server folder. There we go. So it's downloading the image. This is the Postgres image. It will do this for each of the images. Now here we've saved ourselves the build step, which, like I said, takes 5 to 10 minutes. But the download is going to be bigger because it's a pre-built image that has a bunch of stuff installed on it. But the download is, depending on your connection, faster than building it manually from scratch.
And sorry, why is that different on this than on the Windows?
It's different because I configured this differently. It's not different because of Mac.
Right. It's this one we're using a pre-built image, and the other one we're not.
Yeah. And what I'm trying to illustrate here is how quickly, like a brand new developer with a well-built image, going from, having just set up all their credentials, can get set up with the development environment.
Cool.
So you see, there's no build steps there. It didn't install any Python packages. It didn't run npm or anything like that. So here we have it failing to. Oh, I thought I had fixed this. Give me a moment. I've had this problem before. So I've set up the environment file to just point to the environment's npm private token. So as long as that's in your bash profile, this should work. For some reason, it looked like it wasn't working just a moment ago, so I'm going to try this a second time, see if it can read it. It's not liking that. Let's see if I have to source my bash profile. Okay, it's there. There we go. I had to source my bash profile, so it wasn't my npm private token wasn't available to the environment. That's why it was failing. That's it. It's now running. So I can go and I can look at localhost 8000/admin, and there's my Django. My Django logs are back here. This may be another pro or con, but my client logs and my server logs are mixed together. Although I think if you're developing on one or the other, it won't matter because you'll only see the logs for the relevant one. And here's the Vue.js server running with our default hello world message. Let me see if I have VS Code on here.
So the client and server logs are both appearing together even though they're running on separate containers?
That's right, they're talking to each other. So this client, yeah, so they're running in two separate containers, like concurrently. you can think of it as running two different processes. Like you have one tab up running your front end, and you have another tab up running your back end. And then the front end is configured to talk to localhost 8000, where on the host machine, the back end is available.
Right. But we're not looking at one, like that terminal window, we're not looking at the content of one particular container.
Right. It's all Docker Compose has put them together in one stream here. So some other things you could do with this is, right now I'm running Docker Compose in the foreground. I can quit it and run Docker Compose in the background, and I have a sort of a cheat sheet of common commands and stuff like that. So D stands for detach. So it'll run it in a detach mode, so now it's running in the background. I can run Docker PS to see the running processes. So these are the 3 running containers here, and they're the image they're based on, and then the nice names that they have, which are Docker Client 1, Docker Demo Server 1, and Docker Demo Postgres 1. So these are all running in the background. If I refresh this, they are still there. I can do Docker Compose logs, and then F for follow. And then I get the log view again, and I can see what these are thinking about. If I open a new terminal tab here, and let's say I go into source views and I edit this home screen, and I want to change what's on the home screen, just like I would in a normal development environment. I can make that change, and it should auto reload for me because I bound the directories. Let's see if it's thinking about it. I may need to not run it in a detached mode. There are quirks like this.
William.
Yes.
So, first question, does that mean that we need one for each, we need a Docker file for each application that we build?
Yes, I think so. Because
and then what about sorry, I forgot.
Oh, you know what? I think my browser became detached from the development server, so I actually had to refresh the browser, not Docker. Now that I've refreshed the browser and I make changes in here, it should auto refresh. There we go. So we still have the advantages of running these processes the way that we did previously. They will auto reload, and they will respond to changes in synchronized files on the host. We can still use, I don't have VS Code installed on here, but I could still use VS Code as my editor. Right now I'm using Vim for that. The same goes for the background. So if I go into, let's see, is it workspace, Docker Demo Server, manage.py, or rather, and I add a print statement in here. Save that, hop over back to our logs, we see that Django restarted and it did my print statement. So both of those are still working because of that volume binding that we created in the Docker Compose file.
So you know how we usually run npm run dev, and then we see all this in our VS Code or whatever we're using.
Yeah.
Would this replace that, or would it just like be the command that would be to just set up the Docker run?
This would replace, this in theory could replace everything you do to get up to the step where you do manage.py run server, or up to the step where you do npm run dev.
Including that?
Including that step of hitting npm run dev, yeah.
Cool.
So over here, this finished building. So we should be able to do now Docker Compose up over here. And we see it's downloading the Postgres image, but it shouldn't have to download the other images because we just built them locally, so they should already exist locally.
Right. Sorry, and that was my other question about the Postgres. Will it create the user and database for the new user, or do you have to manually create that? It
creates the user and database for the application user. It doesn't create like your super user. You'd have to manually create the super user. That's actually probably the next thing I'll demo here. Well, we're at like 1 minute, so I think we have to wrap this up. I guess, yeah, let me jump ahead. If anyone wants to stick around, I think I have a meeting right after this, but we could do a couple preview commands, or if you have specific questions. But just to wrap this up really quick, this is viable as a solution for development environments. It is very reminiscent to me of the previous sort of evolution of this, which is our virtual machines. And using something like Vagrant, a configuration management tool, along with a virtual machine to provision that machine and get it ready to go as a development environment. It seems like if we have solid images in place and solid build processes in place, this could be a very quick and easy way for new developers to get up and running in our development environment. There's zero custom configuration, as you saw, that you need to do. You just need your credentials to our relevant repositories and stuff like that, and then you can get up and running both with a back end and a front end. You could also independently run the front end or the back end if you just wanted to do development on either one of that. I didn't have time to demo that, but that is possible, just to run one of those Docker containers and have it talk to staging in the same way that we currently do our development. So you don't even have to worry about the server side of things if you're a front-end dev. That said, I think I expressed some of the frustrations I had in setting up these Docker files, and I think that they will add maintenance overhead over the long run. And so to commit to this as the solution for development environments is to commit to that maintenance overhead. But I think, just like anything, it is something that we could learn. And so I guess the next step is think about what you saw here, maybe do some reading on your own. I'll send out the slide deck, which has my list of pros and cons. I'm sure there's more. Yeah, I just wanted to start this conversation. I thought we've all heard about this a lot. It's I've heard a lot of questions about it and stuff. So I just wanted to get this out here. Hopefully, this was a helpful and clear introduction to how this works. So yeah, I'll stick around. I think who do I have? I think Victor. We have a one-on-one right now, right?
Yeah, but I mean, if you want to do this, like I'm